We want to solve this quadratic equation by factoring. Remember, any equation of the form ax squared plus bx plus c equals 0 is a quadratic equation. Quadratic equation, not to be confused with the quadratic formula, which is used to solve quadratic equations. We solved this by factoring, so let's go ahead and factor this thing. All right, so this is our b term 2, our c term is negative 63, and when we factor, we want to find factors of c that add to b. Factors of negative 63, okay, that add to 2. Well, I know 63 is 7 times 9. And let's see here, if we make one of these negative, let's make the 7 negative, 9 positive. Negative 7 times 9 is negative 63. Negative 7 plus 9 is indeed the 2 that we wanted. So those are our two factors. So we have x minus 7, x plus 9 equals 0. Now we hit it with the zero factor property, which tells us to set both of these equal to 0. X minus 7 equals 0, x plus 9 equals 0, which we can then solve. X equals 7, x equals negative 9. All right, so two answers to that one. Let's try another one. Here we have x cubed minus 14x squared plus 49x equals 0. You always want to factor the GCF first. Okay, so anytime you go to factor something, first say, can I factor out a GCF? In this case, you can, right? Look, an x comes out. That leaves us with x squared minus 14x plus 49 equals 0. Okay, now something should jump out to us here. Notice that we have perfect squares in the first term and the last term. Well, there's a formula for that. When you have a perfect square trinomial of the form a squared minus 2ab plus b squared, it factors as a minus b squared. You could also just factor this using other methods and you'd get the same result. So this x still hangs out in the front, and we see that this is x minus 7 squared equals 0. Now we'll use our zero factor property to set each one of these equal to 0. So right out front here we get x equals 0. This one we get x minus 7 squared equals 0. Now the squared doesn't change anything. So really we just want to focus on the x minus 7 equals 0, which tells us that x equals 7. Right, we could think of this, we could take the square root of both sides if we wanted to get rid of the squared. All right, so two solutions there. Let's try another one. Here we have 2x plus 5 times the quantity 4x squared plus 20x plus 25. And notice again, before you spend too much time trying to factor this and going into all kinds of diamond method and all this, we have perfect squares on the first term and the last term. So the first thing you want to check when you see those perfect squares is whether or not this is a perfect square trinomial of the form a squared plus 2ab plus b squared, which indeed it is. So this factors, well, this 2x plus 5 hangs out at the front here, but then this second term, the second trinomial here, factors as 2x plus 5 quantity squared, okay, equals 0. But really, now we actually have 2x plus 5 quantity cubed equals 0. Okay, well, we don't really need the zero factor property here. We just have 2x minus 5 equals 0. Solving that by subtracting 5 and dividing by 2 gives us x equals negative 5 halves. There we go, one solution to that one, which is surprising because it was such a long equation to begin with. Only has one solution.